So let's turn our attention back to the absolute extrema. We said before that if you have a continuous function on a closed interval, then you're guaranteed to get an absolute max and absolute min, but we didn't say how to do it. Now we're going to look at how to do it. All right, so finding absolute extrema on a closed interval. So if you're given a continuous function f on a closed interval, all right, what are you going to do? So this is the procedure we're going to do. We're going to find all the critical numbers of f. We're going to evaluate f at all critical numbers. I should have said here in the interval. So we're only concerned about ones that occur in the interval and at both endpoints. Then we're going to pick the largest value as the absolute max and the smallest value as the absolute min, and that's how we find them. All right. For example, let's find the absolute extrema of f of x equals x squared minus 6x plus 10 on 0, 5. Okay, so what we're going to do is find the critical number. So we're going to take a look at the derivative. So 2x minus 6, all right, which I can also think of as 2 times x minus 3. Now, ask my two questions. When is the derivative equal to 0? When is the derivative undefined and the original function is defined? Well, derivative equal to 0, I think I can see that that's clearly x equals 3. Undefined, none. All right, our derivative is a polynomial. It's defined everywhere. Okay, so that means that we have only the critical number x equals 3. So what I'm then going to do is I'm going to evaluate the function, the original function, because that's what we're looking about finding the extrema of. So I'm going to take this original function, f of x equals x squared minus 6x plus 10. I'm going to evaluate it at 0, at 3, and at 5. I'm doing it at 0 because that was an endpoint. I'm doing it at 3 because that was a critical number. And again at 5, that was an endpoint. So these are all places that I have to consider. So when I go ahead and I plug these numbers in to f of x here, 0 would give me 0 minus 0 plus 10, or 10. 3 would give me 9 minus 18 plus 10, or 1. And 5 would give me 25 minus 30 plus 10, or 5. Okay. Now, these are the only possible places that I could have these absolute extrema on this interval. Now I can just go pick. Well, the biggest value here is 10. That must be my absolute maximum. So I usually say absolute max f of 0 equals 10. Now the truth is that the 10 is actually the absolute maximum, so we're talking about the value of the function there. All right, smallest value, 1. So there's my absolute min. F of 3 is 1. All right, so that was that one. Let's go do another one. Find the absolute extrema of f of x equals 3x to the 2/3 minus 2x on negative 1, 1. Well, start by looking for critical numbers. And so I'm going to start by finding the derivative. All right, so 2/3 times 3, that would give me 2x to the 2/3 minus 1 minus 1/3 minus 2. Okay, and that's my first derivative. Or if I took 2x to the minus 1/3 minus 1, another way to look at that, or 2 times 1 over x to the 1/3 minus 1. All right, so, all right, let's figure this out. We want to find when f prime is 0, and that's one thing. All right, so the only way that that would happen is if 1 over x to the 1/3 was equal to 1. All right, but that's the only way that's going to happen is if x to the 1/3 equals 1, or in other words, x is 1. But I do have to remember, the other thing to consider is when is the derivative undefined, specifically where the original function is defined. Well, look back. X to the 1/3 in the denominator there, so that means that x equals 0 is also a critical number because it makes the denominator 0, hence f prime is undefined there. And note that that's f is defined at x equals 0, so it has that perfect combination. The function is defined, but the derivative is not. All right. So now that I have those values, I'm going to go back. Here's my original function, not the derivative, the original function. All right, so I'm going to do this now at -1, because it's one of the endpoints, 0 as a critical number, and 1, which actually was an endpoint and also a critical number, so I should just do it. Okay, so what do we get? All right, at -1, I get 3. -1 to the 2/3 is 1, minus 2 times -1, so I actually get 5. 0, I get 0 minus 0, I get 0. And at 1, I get 3 times 1 minus 2 times 1. I get 1. All right, well, there's my absolute max of 5. F of -1 is 5. And there's my absolute min. F of 0 is 0. The biggest 5, the smallest 0. All right. How about x over x minus 2. All right, well, as usual, start with the derivative. All right, quotient rule, the top is 1 times the bottom minus the top times the derivative of the bottom over the bottom squared. So we get x minus 2 minus x over x minus 2 squared. So we get minus 2 over x minus 2 squared. Okay. So let's ask our questions. The derivative 0, derivative undefined. Okay. The derivative being 0, well, it can't be. The numerator of this fraction here is minus 2 can't be equal to 0, so none. There's no places where the derivative is 0. Where's the derivative undefined? Now, it's true that the derivative is undefined at x equals 2, but go back. My interval is 3, 5. That's not even on the interval, so I don't need to consider that. So I don't have any critical numbers on that interval. So I don't have any critical numbers to consider for the for the absolute extrema. But remember, we still have the endpoints. So I'm still going to take my function, original function, and I'm going to evaluate it at 3 and at 5, my endpoints. So I get 3 over 3 minus 2, which is just 3, and I get 5 over 5 minus 2, which is 5/3. So I still have 2 points to consider here, and the bigger one's going to be the absolute max, the smaller one's going to be the absolute min. So this 3 is the absolute max, and this 5/3 is your absolute min. Now realize you could get more, you could get the same value, the same maximum or the same minimum at multiple points. Well, they're both or all absolute max or mins in that case. It's the value that we're really talking about. So if we had multiple places where the function was 3 in this case, and that was the highest value, then that would be the absolute max. It just occurs at more than one place.